Precious samples collected from an asteroid are to be moved to a specialist laboratory in Texas in the next few hours. The material, taken from what's been described as the most dangerous rock in our solar system,
So, you ready to see the results of the mission?
NASA recently made headlines by revealing the largest asteroid sample ever collected, igniting excitement and curiosity among scientists and space fans alike. Today we'll look at the incredible voyage of NASA's asteroid sampling mission and the unexpected discoveries concealed within the sample. From precise mission planning and execution to the surprise discoveries within the asteroid, we'll delve deep into the cutting-edge science that made this discovery happen. The asteroids. What are they exactly? Asteroids, those enigmatic space rocks, come in a dizzying variety of shapes, sizes, and compositions, each conveying its own tale about the birth and evolution of our solar system. Consider the asteroid belt to be a bustling celestial highway that runs between Mars and Jupiter. In the expanse of space, millions of asteroids circle around the Sun in highly elliptical orbits, generating a cosmic ecosystem that has captivated both scientists and stargazers. But what precisely are asteroids, and where do they originate? To understand their origins, we must travel back around 4.6 billion years, when our solar system was only starting to form. Asteroids, like scattered puzzle pieces drifting in space, are relics of primordial material that failed to condense into planets during our solar system's chaotic formation. According to NASA, the bulk of asteroids originated in the main asteroid belt, which is located between Mars and Jupiter's orbits. Here, amidst the gravitational tug-of-war between adjacent planets, innumerable rocky particles became imprisoned, generating what we now call the asteroid belt. NASA's painstaking efforts have shown that this cosmic roadway is home to nearly 1 million asteroids of a variety of shapes and sizes, from tiny rocky bits to massive behemoths that dwarf entire cities. Vesta, a massive giant with a diameter of approximately 326 miles, is one of the largest asteroids known to humans. Vesta's position as the largest asteroid was only recently challenged by Ceres, a dwarf planet hidden within the asteroid belt. Despite their massive size, these celestial giants represent only a small proportion of the diverse asteroid population that inhabits our solar system. But size is only one part of the cosmic jigsaw. Asteroids also have a wide range of morphologies, from near-perfect spheres to irregular double-lobed arrangements like huge peanuts. Take, for example, the asteroid Itokawa, whose unusual shape defies easy categorization and demonstrates the complex interplay of forces that shaped our solar system. However, asteroids are more than just relics of a bygone past. They are active, ever-changing entities that continue to shape the cosmic environment even today. While the bulk of asteroids remain within the asteroid belt, the gravitational impact of Jupiter, our solar system's largest planet, can disrupt their orbits, sending them hurtling through space on unexpected courses, including potential collisions with Earth. Despite the inherent dangers posed by these wandering celestial bodies, humanity can be confident that organizations such as NASA's Planetary Defense Coordination Office are vigilantly monitoring near-Earth objects to assess potential threats and devise strategies to reduce the risk of impact. But what are asteroids composed of, and how do they differ from other celestial bodies such as comets and meteorites? To answer these issues, we must investigate the cosmic chemistry that defines these mysterious space pebbles. According to NASA, asteroids are mostly made up of rocky material, earning them the nickname minor planets, since they resemble the building elements of bigger planetary bodies. However, not all asteroids are made equally. Their compositions can vary greatly depending on distance from the Sun and geological history. Some asteroids, known as C-type or chondritic asteroids, are rich in clay and silicate materials, indicating that they formed in the cooler areas of the outer solar system. Others, known as S-type or stony asteroids, have a combination of silicates and nickel-iron, implying a more turbulent past characterized by tremendous heat and geologic activity. Despite this cosmic diversity, one sort of asteroid stands out: the M-type, or metallic asteroid. These craggy space rocks are primarily made of nickel iron, a monument to their turbulent origins in the inner solar system, where temperatures surged and rocky material melted and fused together to form dense metallic cores. scientists have gained invaluable insights into the processes that shaped our cosmic neighborhood through meticulous asteroid sample analysis and remote observations, ranging from violent collisions that sculpted planetary surfaces to the gentle accretion of dust grains that gave rise to the building blocks of life. According to Fred Jourdan, a planetary scientist at Curtin University, asteroids are the initial bricks that built the planets. Asteroids hold a unique place in our collective understanding of the universe, beginning as scattered leftovers of a bygone epoch and evolving into dynamic, ever-changing creatures that continue to shape the cosmic landscape. Whether they originate in the asteroid belt or travel through the inner regions of our solar system, asteroids remind us of the events that gave rise to our cosmic home. A threat to Earth. Meet Paul Chodas, a scientist at NASA's Jet Propulsion Laboratory who spends his days solving the riddles of asteroids. Paul, the head of NASA's Center for Near-Earth Object Studies, is no stranger to the cosmic voyage of these mysterious space pebbles. Armed with cutting-edge software and a lot of information, he is on a mission to solve some of the most important issues regarding asteroids and their possible impact on Earth. So let's start with the major question. How frequently do asteroids hit our planet? According to Paul, it happens less frequently than you may expect. Sure, we've all heard about dinosaurs being wiped off by a giant asteroid millions of years ago, but such catastrophic events are rare. In fact, asteroids large enough to do significant harm strike Earth only about once every century. Smaller asteroids, such as those the size of a desk, collide approximately once a month. But don't worry, they usually merely fade out in the atmosphere, leaving a dazzling light show for anyone lucky enough to view them. But how do we know whether a potentially hazardous asteroid is on our way? That's where Paul and his colleagues step in. Once an asteroid is detected, it is tracked for as long as feasible using Earth-based telescopes. They feed all of the tracking data into sophisticated software, which calculates the asteroid's trajectory and forecasts where it will go in the future. And because of their efforts, we can identify possible hazards years or even decades in advance. In fact, NASA's CNEOS keeps a list of all the asteroids that have even the tiniest probability of reaching Earth in the next century, known as the Century Risk Table. So far, however, there are no known asteroids large enough to do catastrophic harm that have a good chance of reaching Earth in the foreseeable future. But what precisely are near-Earth objects, and why should we care about them? NEOs are asteroids or comets with orbits that bring them close to Earth. The majority of asteroids are located in the asteroid belt between Mars and Jupiter. However, NEOs occasionally do pay a visit, sometimes known as potentially hazardous objects. But don't worry, NASA maintains a tight eye on these cosmic wanderers, and thus far, none of them are on a crash course with Earth. Now let's talk numbers. How many potentially deadly asteroids are out there? According to NASA, there are presently 586 confirmed PHOs. However, this figure is constantly changing as new asteroids are discovered and older ones are tracked more accurately. While this may appear to be a large number, it represents only a small proportion of the total number of asteroids in our solar system. But do asteroids actually hit Earth? And if so, how frequently? Yes, they do, but thankfully, not often. According to NASA, about 100 tons of space material falls to Earth each year, with asteroids accounting for a significant portion of that total. However, impacts are much less common now than they were in the early days of the solar system when Earth was pounded by asteroids on a daily basis. Sure, there are outliers, such as the legendary Chicxulub impactor, which wiped out the dinosaurs millions of years ago, but big asteroid strikes are relatively uncommon. Every day, thanks to the efforts of scientists like Paul Chodas and institutions like NASA, we learn more about these cosmic wanderers. The Osiris Rex Mission. NASA's Osiris Rex Mission is a groundbreaking space exploration mission that aims to reveal the mysteries of our solar system by analyzing and collecting samples from asteroids. Osiris Rex launched on September 8, 2016, with the primary purpose of exploring asteroid Benu, a near-Earth object that has priceless information about the early solar system. The mission's name is Osiris Rex, which stands for Origins, Spectral Interpretation, Resource Identification, Security, and Regolith Explorer. It was chosen as a finalist for NASA's New Frontiers mission class in 2009, along with other ambitious programs aiming at expanding our understanding of space, such as missions to Venus and the Moon. Osiris Rex emerged triumphant in 2011, allowing it to embark on its enormous mission. Osiris Rex began its trip from Cape Canaveral Air Force Station in Florida when it was launched on an Atlas rocket. This $800 million mission was a notable milestone in space research since it planned to be the first U.S. spacecraft to collect samples from an asteroid and return them to Earth for study. Following its launch, Osiris Rex did not proceed directly to Benu. Instead, it performed a gravity assist maneuver, swinging by Earth in September 2017 to boost speed and modify its course toward the asteroid. This gravitational push from Earth helped accelerate Osiris Rex to Benu, paving the way for its historic encounter with the space rock. Osiris Rex arrived at its objective, asteroid Benu, on December 3, 2018, after traveling across space for more than 2 years. This carbon-rich asteroid, which was about 1,640 feet in diameter, provided a rare opportunity for scientific research. As Osiris Rex approached Benu, it obtained breathtaking photographs of the asteroid's rough landscape, revealing tantalizing glimpses of the secrets that are still to be discovered. Osiris Rex got right to work as soon as it arrived. It began by methodically investigating Benu's surface, using an array of advanced equipment to determine the asteroid's terrain, temperature, and composition. Among the instruments aboard the spacecraft is the Osiris Rex visible and infrared spectrometer. This instrument used visible and near-infrared light to detect minerals and organic compounds on Benu's surface. The Osiris Rex Thermal Emission Spectrometer measured Benu's thermal emissions to map its mineral and chemical composition, revealing important information about the asteroid's geology. The Osiris Rex camera suite with 3 cameras, Polycam, Mapcam, and Samcam, OCAMs, obtained high-resolution photos of Benu, allowing scientists to investigate its surface features and choose an appropriate sample site. The Osiris Rex Laser Altimeter, using the laser beams, surveyed Benu's surface and created detailed 3-dimensional maps to aid with navigation and sampling. The Regolith X-ray Imaging Spectrometer studied X-ray emissions from Benu to establish its atomic composition, providing important information for understanding the asteroid's creation history. This equipment worked together to reveal Benu's secrets, clearing the groundwork for the mission's most important phase, sample collecting. On October 20, 2020, Osiris Rex made history by touching the surface of Benu and collecting a sample of regolith, loose gravel and dust, with its touch-and-go sample acquisition mechanism. This brief touch with the asteroid's surface was the product of years of preparation, engineering, and scientific research. With the sample safely on board, Osiris Rex set out on its voyage back to Earth, bearing valuable cargo from an ancient solar system relic. On May 10, 2021, the spacecraft bid farewell to Benu and began its return journey, arriving in the area of Earth on September 24, 2023, after traveling millions of miles through space. In a historic event seen by scientists and space enthusiasts all across the world, the spacecraft released its sample return capsule, which dropped through Earth's atmosphere and safely landed in the Utah desert. The successful retrieval of the asteroid sample was a triumph for NASA and the international scientific community, opening up new paths of research and discovery. But Osiris Rex's mission wasn't over. Buoyed by its success on Benu, the spaceship began a new stage of exploration, focusing on another exciting destination, asteroid Apophis. This near-Earth asteroid, known for its close interactions with our planet, provided an opportunity for Osiris Rex to broaden its scientific research and push the limits of space travel. As Osiris Rex approaches Apophis, scientists excitedly await the abundance of knowledge and insights it will bring back to Earth. The relevance of the project extends far beyond space exploration, from uncovering the secrets of asteroid formation to acquiring a better knowledge of planetary defense against possible impact threats. It depicts humanity's restless curiosity and unwavering pursuit of knowledge, which drives us to explore new horizons and uncover the mysteries of the universe. As Osiris Rex continues its journey through space, it encourages us to dream large, aim for the stars, and push the limits of what is possible. Searching for samples. Now you might be wondering, why Benu? What makes this strange space rock worth exploring? Benu was originally designated as 1999 RQ-36 and earned its new name during a NASA contest held in 2013. The winning answer, suggested by 9-year-old Mike Puzio, named the asteroid Benu after the Egyptian mythological bird god represented as a gray heron. Puzio's explanation for the name was both poetic and pragmatic. He perceived a parallel between Osiris Rex's touch-and-go sample acquisition mechanism and the solar panels, as well as the ancient deity's spread wings and long neck. However, Benu's appeal goes far beyond its intriguing name and fabled associations. Its orbit brings it perilously near to Earth, making it accessible to probes such as Osiris Rex. Unlike smaller asteroids that spin quickly, Benu's size, approximately 500 meters in width, provides a stable surface for safe landing and investigation. Furthermore, Benu's composition is rich in carbon-based compounds, which is an exciting potential for scientists looking for clues regarding the origins of life in the universe. Asteroids such as Benu may have played an important role in bringing water and organic molecules to Earth billions of years ago, creating the primordial soup from which life originated. Researchers want to uncover the molecular constitution of Benu and the secrets of our cosmic ancestors by analyzing it up close. Nonetheless, Benu's proximity to Earth raises concerns about its potential as a dangerous object. With its orbit overlapping Earth's path, Benu offers a conceivable risk of colliding with our planet. While the likelihood of such an event is low, NASA puts the possibility of impact up to 2,300 at 1 in 1750. An asteroid the size of Benu may damage the surrounding area upon impact, but not cause global extinctions. Thus, Osiris Rex's mission to Benu is more than just scientific investigation. It also includes planetary defense. Scientists hope that by researching Benu's trajectory and composition, they will be able to create measures to mitigate future asteroids. The advanced warning offered by missions such as Osiris Rex could be extremely useful in developing proactive techniques to deflect or redirect asteroids on a collision trajectory with Earth. Its new target, asteroid Apophis, was previously considered a potential threat to Earth, but has now been removed from the Century Impact Risk Table following improved calculations of its orbital trajectory. However, Apophis continues to pique scientists' interest, causing NASA to reassign Osiris Rex to examine this intriguing asteroid. The spacecraft, renamed Osiris Apex for its extended mission, will approach Apophis in 2029, equipped with a suite of equipment to analyze the asteroid's composition and structure in unprecedented detail. Despite the problems provided by aging spacecraft components and increased expenses, the possible benefits of investigating Apophis exceed the hazards. Apophis's close approach to Earth in 2029 provides a great chance for scientific discovery and planetary protection. By studying this asteroid's properties, experts expect to acquire a better understanding of its origins and evolution, revealing information on the dynamics of our solar system. A brief pause while we bring you our subscribers' pick. NASA just opened the largest asteroid sample but saw unexpected things inside. In 2015, the European Space Agency's Rosetta spacecraft made headlines when it arrived at Comet 67P Churyumov-Gerasimenko and discovered that it had an unusual rubber duck shape. This comet is a Jupiter family comet, meaning its orbit is influenced by Jupiter's gravitational pull. It was discovered in 1969 by Ukrainian astronomers Klim Churyumov and Svetlana Gerasimenko. The comet's two distinct lobes give it the appearance of a rubber duck, with one larger lobe resembling the body and the other smaller lobe resembling the head. Rosetta's mission to Comet 67P was groundbreaking, as it provided scientists with unprecedented close-up observations of a comet's nucleus and its activity as it approached the Sun. The spacecraft deployed a lander called Philae, which made the first ever controlled landing on a comet's surface in November 2014. The data collected by Rosetta and Philae revolutionized our understanding of comets and their role in the solar system's formation. Scientists discovered that Comet 67P is rich in organic molecules, including complex carbon compounds, suggesting that comets may have played a significant role in delivering the building blocks of life to early Earth. Do you believe life as we know it is a result of such asteroids colliding with Earth? Let us know in the comments below. Previous sampling missions and Osiris Rex. Asteroids are like time capsules containing information about the universe's formation. They provide a look into the past, showing the conditions and events that contributed to the formation of our planets. Sampling missions, such as Osiris Rex, are among the most intriguing aspects of asteroid exploration. However, it continues in the footsteps of Japan's successful Hayabusa missions. Hayabusa, launched in 2003, was the first spacecraft to return samples from an asteroid when it returned material from the asteroid Itokawa in 2010. Hayabusa 2, its successor, duplicated the feat in 2020, gathering samples from the asteroid Ryugu. Unlike past missions like NASA's Dawn, which investigated asteroids from orbit, Osiris Rex intended to directly acquire a sample from Benu's surface. This hands-on technique enables scientists to do detailed laboratory investigations that are impractical to do remotely. The mission's main scientific goal was to retrieve at least 2 ounces of material from Benu. This may not seem like much, but even a small sample can provide valuable information about the asteroid's history and evolution, helping scientists learn more about Benu's origins and significance in the early solar system by examining the chemical and mineralogical composition of the gathered material. In addition to its scientific goals, Osiris Rex has a secondary mission to investigate potentially hazardous asteroids. While Benu does not pose an immediate threat, examining its orbit and composition can help scientists better understand pH dynamics and design planetary defense systems. Another noteworthy component of the Osiris Rex project is its examination of the Yarkovsky effect. When sunlight heats an asteroid's surface, it emits thermal radiation, which slightly affects the asteroid's trajectory. Over time, these little nudges can have a considerable impact on an asteroid's journey through space. Scientists think that by researching the Yarkovsky effect on Benu, we may be able to better forecast asteroids' trajectories and reduce the chance of collisions. The asteroid sampling missions such as Osiris Rex are paving the way for a better understanding of our solar system's evolution and dynamics. The DART mission. Saving Earth from an asteroid impact is more than just a Hollywood movie storyline. It is a serious concern for scientists. According to NASA, only around 40% of huge asteroids have been identified, emphasizing the need to be prepared for such an event. While there are several possibilities for diverting asteroids, only one has been tried in practice away from Earth's surface: the Double Asteroid Redirection Test mission. The objective of DART was clear: to demonstrate NASA's capacity to use a kinetic impactor to modify the trajectory of a tiny asteroid. This technique involves crushing a spaceship with the target asteroid, causing a slight shift in velocity. The concept is that if an asteroid approaches Earth with plenty of warning and is not too huge, a spacecraft like DART, ensuring it misses Earth many years later. In September 2022, DART successfully reached its target, the asteroid Dimorphos, and altered its orbit as anticipated. This was the first time humans purposefully altered the course of a celestial object. The mission emphasized the significance of advance notice, or lead time, for such planetary defense activities. Understanding what asteroids are made of is critical to developing successful mitigation techniques. Different asteroids require different diversion strategies depending on their makeup. Some asteroids are solid pieces of metal. Pushing these various types of asteroids away would necessitate varied strategies and variable quantities of energy. By examining asteroids and meteorites, scientists might start to anticipate problems and develop solutions accordingly. This early planning is critical because it ensures that when the need for precise and exact action occurs, we are prepared to act quickly and efficiently. Agencies such as the Center for Near-Earth Object Studies are crucial in monitoring the skies for asteroids, analyzing their orbits, and forecasting their future courses. This ongoing surveillance not only protects humanity from future asteroid impacts, but also gives priceless information about the origins of our planet and its neighbors. DART's impact on Dimorphos extended beyond simply modifying its orbit. It actually changed the asteroid itself. Dimorphos was originally an oblate spheroid that resembled a crushed ball. However, DART's high-speed collision drove shockwaves through the asteroid, elongating it and pushing its axis of spin-off center. As a result, Dimorphos changed into a triaxial ellipsoid, which resembled an oblong watermelon. The impact also released a chunk of Dimorphos's bulk into space, redistributing the remainder throughout its surface. These findings indicate that Dimorphos is not a solid, hard object, but rather a loose debris pile held together by weak gravity. This discovery offers light on asteroids' behavior when subjected to kinetic energy and gives crucial information for future planetary protection efforts. It shows that changing an asteroid's trajectory is possible, but it takes careful consideration of its composition and structural integrity. DART's achievement brings up new possibilities for asteroid deflection devices and expands our understanding of these enigmatic space rocks. The future of asteroid mining. Asteroid mining is a domain of untapped potential hidden in the magnificent cosmos. It's a notion that straddles the border between science fiction and reality, predicting a future in which mankind travels beyond Earth's boundaries to harvest the huge resources of the universe. But what does asteroid mining entail, and what are the challenges and opportunities that await? Consider a setting straight out of a science fiction novel, a thriving mining village situated on the surface of a double asteroid designated 90 Antiope. This celestial outpost, located in the main asteroid belt between the orbits of Mars and Jupiter, portrays humanity's future among the stars. But this image is more than just a fabrication of the mind. It's a tantalizing peek of what might become a reality in the not-too-distant future. At the heart of the asteroid mining effort is the promise of vast riches. Advocates of space mining highlight the enormous amounts of prospective riches, claiming that billions, trillions, and even quadrillions of cash are available for the taking among the asteroids. It's a concept that has captivated the imaginations of entrepreneurs, scientists, and visionaries alike, causing a surge of interest and investment in the developing field of space travel. However, beyond the appeal of cosmic riches lurks a challenging landscape. History is littered with the remains of unsuccessful space mining efforts as lofty goals collided with the harsh realities of space. Despite previous losses, the idea of asteroid mining continues, propelled by technological improvements and a rising realization of the importance of space resources. Angel Aboud Madrid, director of the Center for Space Resources at the Colorado School of Mines, discusses the growth of space mining objectives. He recalls that a decade ago, there was much enthusiasm and conjecture about becoming trillionaires in space. However, lofty ideas failed due to logistical and economic obstacles, leaving ripped and tattered company plans. The space mining landscape is constantly changing. Dozens of startups and larger companies are actively exploring the extraction of resources from celestial bodies, each with its unique strategy and technology. However, as Aboud Madrid notes, the route forward is much more apparent. The future of space mining raises several key questions. Who will collect the essential information to identify valuable resources? Who will create the technologies for extraction and processing? And perhaps most crucially, who will foot the money for these grandiose projects? In recent years, space mining operations have switched to the moon. Its accessibility and familiar topography make it a desirable location for initial exploration and resource extraction. However, the ultimate target remains the asteroids, those ancient leftovers of the solar system that carry the potential of enormous wealth. However, as Aboud Madrid warns, the path to asteroid mining success will require more than simply technological prowess. Legal and diplomatic considerations are important, as issues of ownership and resource rights must be resolved in an organized, efficient, and sustainable manner. Missions to asteroids have gained traction in recent years, delivering vital information on their composition and prospective resources. However, the next hurdle is to harvest these minerals from asteroids. TransAstra is a California-based company that aims to improve space travel by extracting resources from the moon and asteroids. TransAstra, led by CEO Joel Sercel, has developed a revolutionary technology for asteroid finding and resource extraction. Their sky-scanning technology, which includes smart software and low-cost telescopes, is designed to identify asteroids that are easily accessible and suitable for mining. Transastra has also experimented with optical mining, which uses intense sunlight to mine and extract fuel from volatile-rich asteroids. Ultimately, the purpose of asteroid mining is to extract resources in a way that is both sustainable and helpful to humanity. Sercel highlights that space exploration provides solutions to problems on Earth, promising a prosperous future for humanity amid the stars. Thanks for watching. Stay tuned for more.